All right, so those examples I gave were examples of functions that actually made a shape that we could find the area of. So sometimes we're going to be given functions of a shape that we can't find the area of. And we're going to approximate the area underneath those curves using a method called the rectangular approximation method. Okay. Okay, or called RAM. Okay, so the rectangular approximation method is you create rectangles. I can't spell. Under a curve to approximate the area. Okay, so we're going to look at the function. We're going to say that v of t equals t squared plus 1. Okay, and we are going to approximate the area from t equals 0 to t equals 3. Okay, so I'm going to sketch a picture of that. Okay, so we've got 1, 2, 3. 1, 2, 3, 4, 5, 6, 7, 8. It's going to go up to 10 because it starts at 1. We have 1, 1, 2, 5, 1, 2, 3, 4, 5, and then 3, 10. Okay, so my curve's kind of like this. Okay, and we want to try to figure out what the area under that curve is. And the first thing we're going to do is use what is called the right rectangular approximation method. Okay, so all that means is, also called RRAM, all that means is we are going to use, when we split this up into 3 rectangles, okay, we're going to use, sorry, I should have put that up here, 3 rectangles. Okay, when we split that into 3 rectangles, we are going to use the right rectangles for the, we are going to use the right side of the rectangle for the height. Okay, so this is velocity versus time. Try to focus that a little bit better for you guys. Okay, so when I look at this first rectangle, I am going to look at that height. Well, that height is 2 times my base, which is 1. Okay, plus, when I look at this rectangle, that height is 5 times my base, which is 1. And when I look at my last rectangle, my height is 10 times my base, which is 1. Okay, so what does that give us? 10, 15, 17. So we would call this an overestimate because there's quite a bit of area, even if there's not quite a bit of area, even if there's just a little area over the curve, it is an overestimate. Okay, so this is an overestimate. Okay, and that is the right rectangular approximation method. Okay, now we're going to do the same thing, and I know I'm off the screen right now, but we are going to use the left rectangular, I'll move this up in just a second, approximation method. okay, or LRAM. Okay, so we're going to do the same thing. We're going to have the same curve. Okay, I've got my velocity and my time. But now, I know you'll never guess, we are going to use left side of the rectangle for the height. Okay, so if I look at these rectangles again, now I'm looking at it from there. So this is going to be the area I calculate. So that height is 1 times my base is 1. Plus this height is 2 times the length of my base, which is 1. This height is 5 times my base is 1. So we get 8. And this is what looks like an underestimate, right? Because these are under my curve. Okay, I've got all this leftover area that we're not accounting for. Okay, which hopefully maybe some of you are thinking, hey, what if we use the middle? That might make it a little closer. Absolutely, the middle is going to make it a little better. And we're even eventually going to use trapezoids, which maybe some of you are thinking as well. So if you're thinking that, good job. But that's not until later in this chapter when we get into trapezoids. So this is what you're going to be doing for homework. Mr. Cruz has your homework assignment for you. So just get that from him and then work on it with each other. I have left answer keys for you guys. I left the solution manual for you guys to be able to look at, to be able to check your answers. So you have all those tools at your resources. You also have my phone number. I'm in a conference, so I may not be able to answer immediately, but if you do have some questions, you can text me and I will do my best to get back to you as soon as I'm available to. So please do your best to get some of this done this week. We really are starting to get behind. I'm not super worried, but I'm a little worried. So I need you guys to really try to be productive these 3 days while I'm gone, as hard as that is going to be. All right. So good luck with that, and I will make you guys some more videos for the rest of the week.